Okay, I'm going to try to do a two-step process here. Um, I'm going to cluster some data and uh, then do a neural network based on the clustering. You'll see what that means in a little while. This is working with the data from geoinformatics.org, and we're trying to predict gusts, and we're treating gust as uh, nominal, a binary nominal variable. So it's either yes or no. There is a gust or there isn't. And in previous videos, I showed how to one way to achieve that. Um, we're going to use something here called a filtered cluster. Filtered clusterer. We're going to use something called the remove filter. We're going to be able to add the cluster variable to the data set. I guess you'll see what that means also. Um, we're going to split into a training set and a testing set. What else are we going to do here? We're going to use something called subset by expression. So that's taking a subset of a data set, and we'll do something like that as well. I have some data here, which I think I already prepared. I started with CSV files that I downloaded from the website, and let's see, what do I have here? Train with, so I split this data set up into two, training and testing. I did some other modifications and saved them as well, but the original one is here. Training from the Kume weather station, April 28th to June 6th. And let's look at this to see what it looks like. 1 second. Move this away. And here. And here. And look at it. So you can see that there's a number of different variables here. Now I thought I changed. Oh, I didn't change. And so this last variable is called now plus 30. In other words, it's the it's whether or not it's a it says it's numeric, but it's actually a 0, 1 variable, I think, and it's whether or not there was a gust or not 30 minutes after these measurements from here to here. So the date, time, the temperature, the humidity, the rainfall, the pressure, the wind speed, and the dew point were all taken at a certain time, and then this is 30 minutes later. Now there's a way to do this with another filter, but I did this by hand. So maybe I'll try it with the other filter later, but anyway, it's already done now. Okay, so this is the training data set, and then I also have the same thing here with the testing data set. If you look, I gave them these long names, but anyway, if you look at this one, you can see that I have the same thing, but this is the testing data set. So it's the same thing. Okay. Then I did some processing of these, and I think that what did I do next? Well, maybe I'll start from scratch and try and do it again. Show you what I did. So let me make a start from scratch and take these two, this one, the training, put it in there, and the other one, the testing one, in there. Okay, so maybe I'll just do that. Now, let's see if I can get all of this straight. There's a lot of things that I'm going to do here. It may be good to do this, by the way, in the other interface. what's the other interface called? Knowledge flow interface. But anyway, I'm going to do it here in Explorer. So I'm going to open up, let's see, maybe I need the instructions. So I split it into test and train. I saved it as R files. Now I have to make these, as you saw when I opened it up, they weren't, the last variable was not nominal. I want to make it nominal. So I'll do that first. So I'll open that file to drill down to get it. Maybe just for now, I'll just, well, okay. And I'll do this first with the training data. And I'll click OK. And I need first to make this nominal. So it's currently numeric. Okay, so I go to the filter section and I go to unsupervised, hopefully, and I want to work on the attributes, not on the records. Pardon me. And so numeric to nominal here. Now it's going to make everything numerical to nominal. It says first to last. That is, it's going to make all of these nominal, which I don't want to do. So I click up here and change this to 8, the 8th attribute or the 8th variable only. And I click OK. And I click Apply. And I check. I check here, and I check up here, and I see that it's now nominal. So now I want to save this. Did I give it any particular name? No. So in fact, I'm just going to save with the same name. So I'm going to overwrite the other one. Okay, then I'm going to do the same thing with the testing data. So this is, if I check it, it's numeric. If I apply this, and I check it again, it's nominal. And I save it and overwrite it. And click yes. Now let's see if it really worked, because sometimes I've seen that it didn't actually work. By the way, I'm just going to take these and put these out here just to make it a little bit faster. So if I check them, are they really now? So let's see. So this is 0, 1, nominal. And this is also 0, 1. Okay, so it's okay now. Now, what else do we have to do? Now I want to do the filtered clustering. And that's like clustering, but it allows you to do a little filtering at the same time. Okay, so what I want to do is remove the class variable, that is the Gus, from the clustering. And the reason I want to do that is because I'm going to be basically doing something, I guess you could say I'm going to be clustering the training data and the testing data. That's not quite true. I'm not really clustering the testing data, but I'm doing something like that. I'll maybe explain that. But so the thing is, I don't want to, since part of what I'm doing here is working with the testing data, I don't want to include any information about the gusts in the testing data. Otherwise, that would sort of confound the results. That would, be using as input basically the gusts to predict the gusts. And that doesn't make any sense, because normally you wouldn't have gusts as input, or if you did, you wouldn't as input into your prediction process. If you did, you wouldn't be predicting. So I don't want to include that, so I want to do this kind of filtering. So let's see how that works. And it's called filtered clustering. Let's see if we can get this to work. So first of all, you want to open the training data. Okay, let's make sure that it's still nominal. Still is, okay. And then I want to cluster it, and I choose from the list of clusters. Now, usually we've used the simple k-means, but we're going to use this thing called filtered cluster, which is still going to allow us to use simple k-means, but it gives us a different interface to use it. So let's do that. Now, if I click on this to see the interface, you can see that I can still choose the cluster that I want, and I want simple k-means. But I get one more option here. How do I do that? Close it. And that is I can choose a filter at the same time. What filter did I want? I want to choose the remove filter. And I want to remove attribute 8. I hope it's attribute 8. Let's hope so. Now I forget where the, let's see, I want to remove an attribute. Now I don't remember if this is under supervised or unsupervised. But let's see. Remove. Yeah, just this one here. Okay, remove. Now if I click on that, I can say the attribute indice that I want to remove from the clustering process. So I guess what this does is it clusters, but it ignores the whatever attribute I indicate here in the when it's doing the clustering, when it's deciding which records are close to each other. It doesn't consider the 8th attribute, since I'm going to write 8. Let's click OK, and click OK. I just want to make sure that it was actually the 8th attribute that I wanted to remove. It is. So that's fine. Okay, now, here's the trick. I could just do this now and cluster, but you saw that I'm only working on the training data. What I really want to do, though, or in addition to building the clusters in the training data, is I want to take the testing data, say any particular record in the testing data, and I'd like to know which cluster it belongs to. When I say which cluster it belongs to, I mean from within the clusters that have just been developed by the training data. So I'll say that again. I want to take a record from the testing data and decide which cluster it is closest to. And by cluster, I mean clusters that were developed in the training set. Because then what I want to do is I want to use just that cluster to build the neural network model. And hopefully that will give me a more accurate prediction because I'm sort of only using data that's similar. So that's the idea. So in order to do that, now if I just left it like this, I would just be clustering the training data, which would be fine, but that's not what I want to do. I want to cluster it and at the same time, as I just said, take each element in the testing set and find out where to assign that. So let's see how. So the way you do that is you use the supply Okay, actually I'm going to stop here and continue in a moment.